So as I mentioned, my name is Mete Atamel. I work at Google in London. This is my Twitter. Mete Atamel is my hashtag. I'm going to put the slides there, so if you want to get the slides, feel free to just follow me on the Twitter, and you'll have the slides. And I'm originally from Cyprus, and I'm flying to Cyprus after this, so I have to get out of this talk and go to the airport right away. So I'm not sure if you're going to have any time for questions, but you can always reach me on Twitter, and I'll be happy to answer any questions that you have there. All right, so my talks usually go as why, what, and how, because I think every time you look at some kind of technology, it's important to understand why you should even care about the technology. So that's the first part of my talk. Then we're going to look at what is Istio, what does it provide to you. So that's the second part. And lastly, we're going to look at the details. So how can you actually use Istio in your applications, and what kind of things it provides to you, like add-ons and traffic management, stuff like that. All right, so let's first talk about the why question, the need for Istio. Before I start my question, my talk on Istio, who here uses containers today, uses Docker? Okay, a few people. And then who here uses some kind of container management platform, such as Kubernetes? Okay, a few people as well. So Istio depends on containers and Kubernetes, so that's why in the first part of my talk, I want to briefly cover what containers are and briefly cover what Kubernetes is, so that we are all on the same page, and after that, I'll get into Istio. So what is a container? When you think about it, a container is nothing more than a different way of virtualizing your applications. So back in the day, we had physical machines where we would deploy everything, and then we virtualized them into what's called virtual machines. So we were virtualizing the whole operating system and everything that goes on top of that. And now, instead of virtualizing the whole operating system, we are virtualizing the process, the actual process that runs your application, and its dependencies. And because we are virtualizing much less than before, these containers, they're much more lightweight than virtual machines. But in the end, the reason for containers to exist is that to virtualize your application. So they are lightweight, sealed and isolated, meaning you can have multiple containers running on the same machine. They're very easy to deploy, so it takes seconds to deploy to a container. They're introspectable, so that means that you can actually get into the container as if it's a virtual machine and see what's happening. And for me, the most important part of containers is that they're composable. So you can create your own image for your application that can depend on a base image, and then someone else can build their image on top of your image. So these dependencies can be layered, and each layer is individually cached, meaning that if you have two containers, two images depending on the same base image, you download that once, and then they can share that image in their applications. So that's what containers are, but Docker made containers really easy for us. So the concepts of containers, they've been around for a long time, and at Google, we've been using containers for more than 10 years, but they weren't accessible to everyday developers. So what Docker did is that they created a framework, and they created this notion of Dockerfile that makes it really easy to use containers. So the idea of the Dockerfile is that you define your dependencies, you define your environment, and you define your application in a single file, and Docker makes sure that that application and that environment of that application runs exactly the same way. For example, in here, we have this simple Docker file. The first line says from Debian latest, so that's your dependency image. So we are depending on the latest version of Debian. Then we are now installing some packages. So here we are installing Nginx. And then we are exposing our port 80 for Nginx. So we are basically setting up our environment. And then here with the command line, we are defining what happens when our application runs. So here we are just running Nginx with some options. So in a single file, we are defining our dependency, our environment, and our application. And Docker creates this context for our application to run. And it makes sure that this context is exactly the same way on my laptop. It's exactly the same way in the cloud, everywhere. So that's great. We have this context, but just having this context is not enough when you think about applications. So you need to, for example, do redundancy. You need to have multiple containers, and you need to manage them yourself. If your application is successful, you probably need to scale up. So you need to add more containers to your cluster. And then if less people are using your application, you probably want to scale down. You need to think about service discovery. So how do you discover services within your cluster? You need to think about rolling out new versions. So if you have containers running in the cluster with version 1 of your application and you want to upgrade to version 2, how do you do that in a consistent way? you need to worry about configuration and secrets. So how do you define your configuration, and how do you get the configuration into your container? So there's all these questions that you need to answer, and you need to implement yourself. So just because you took your application and containerized it doesn't mean that these problems go away. You still need to worry about them. So that's why we have Kubernetes. What is Kubernetes? First of all, it's a Greek word, as you can see from the Greek letters, that everyone mispronounces. Because the right way of saying Kubernetes is Kubernetes. But since Kubernetes came out in the US, and people in the US, they tend to mispronounce things, they started mispronouncing Kubernetes, and we're stuck with this name right now. But it's an open source project, 100% open source, written in Go. It came from something called Borg. So as I mentioned before, at Google, we've been running containers for a long time, and we created this internal container management platform called Borg. So people who worked on Borg, they learned from it over the years, and they created Kubernetes for everyone else. So it came from the ideas that made Borg work. And for me, the biggest thing about Kubernetes is that when you are dealing with Kubernetes, you're not thinking about machines anymore. You're thinking about applications and scheduling containers onto the infrastructure that you have, but you're not thinking about virtual machines or anything like that. And also, one of the biggest things about Kubernetes is that it runs everywhere. So it runs on your machine, it runs on AWS, it runs on Azure, it runs on Google Cloud. So once you adopt Kubernetes, it gives you a lot of options on the where you can run it. So it's up to you, basically, where you want to run Kubernetes. So in this containerized Kubernetes world, a microservice looks something like this. First, you have your code, but you need to containerize your code, so it goes into a container. Then from there, you create what's called a pod template. So a pod is this a pod is the smallest unit that Kubernetes runs. So you create a template for it, and then you tell Kubernetes what you want to be true. So in Kubernetes, there's something called replication controller. So here we are saying we want to have 3 copies of this pod running at all times. And Kubernetes, I will have some water. And Kubernetes looks at your infrastructure. So these are the nodes that you have. These are the nodes that you have in your cluster. It will look at the nodes, and it will figure out how to create these pods and how to schedule them onto your nodes. And once your pods are running, you want to expose them to the outside world. So you create what's called a service. A service is kind of like a load balancer for your pods. And the service has a stable virtual IP. So people from outside will get to your service, and from the service, it will get to your pods, running to your pods. So in this world, a microservice is not just your code anymore. It's a combination of your code via the container, but also it's a combination of what Kubernetes provides in terms of replication controller, pods, services, and many other things that Kubernetes provides. All right, so that's Kubernetes. But the thing is, Kubernetes is not enough either, because when you want to run microservices in production, you need to think more than just containers. You need to think about logging. So what kind of logging framework you want to use, and how do you collect logs, and where do you send them, and how do you visualize them? You need to think about tracing. So if you have multiple microservices, you probably want to trace the HTTP calls, and you want to see how long the time is being taken between them. You probably want metrics. So you want to keep track of some metrics in your microservices and send them somewhere so that you can visualize them. You probably want to think about traffic flow. So how does the traffic flows in your system, and how can you set policies for those traffic, right? So if you want to limit certain microservices calling other microservices, you need to think about that, and you need to set policies, and you need to enforce them. You need to think about failover. So if a microservice doesn't work, where do you fail over, and what happens? And for testing, you probably want fault injection. So if you have microservice A calling microservice B, and B calling C, what if you inject some delay, or you inject some kind of fault and see what happens? Does your microservice behave the way it's supposed to behave? So there's all these things that you probably should be doing, even if you're not doing today, but Kubernetes doesn't help. So Docker gives you the context. Kubernetes makes sure that your container runs, but these problems are still your own problem, right? So that's why we have this, Istio. This is the logo for Istio. And what is Istio? It's another Greek word, as you can see. I don't know why open source people are obsessed with Greek words. But the good thing about Istio is that it's not mispronounced now. Everyone pronounces it correctly. And Istio, in my mind, it has 2 high-level goals. Number 1 goal is, and it's an important goal, is that it's about community coming together and agreeing on a common set of tools and common set of practices, right? So we all want logging. We all think that tracing is a good idea. We all think that dependency visualization it's a good idea. So why don't we come together and pick the best tools for the job, and also give you a framework to use them. And if you want to use something else, also make it pluggable so that you can plug in whatever you want. So that's the main goal of Istio in my mind. And the second thing is that Istio enables you to decouple your application code from the underlying infrastructure. So normally, your application code should be solving the application problems. It shouldn't really care about where it's running, whether it's being managed by Kubernetes or not, right? But this is very hard to do because when you run in an environment, the environment details, they kind of seek into your application code, and that creates unnecessary dependency onto the infrastructure. But Istio, with the tools that it provides, it tries to break that dependency so that you can take your code and run it anywhere you want and let Istio worry about the underlying infrastructure, okay? And at the very high level, this is how a Istio cluster looks like. So let's imagine you have users talking to a front-end microservice, and the front-end microservice talking to some other microservices, maybe a pictures microservice and a payment microservice. Then maybe you have an authentication service that's using a database in the backend, and maybe the payments microservice talks to an external payment processor, right? So let's imagine that you have this kind of setup, and you want to install Istio into this microservice cluster. Once you install Istio, this is what happens. So you get these pieces, these Istio pieces injected into your cluster. The first thing that you'll realize is that there's an ingress. So ingress is kind of like the entry point to your cluster. All the traffic from outside goes through the ingress. So it's kind of like a gatekeeper to your cluster. And then you'll also realize that every container gets a proxy. So every pod will have a sidecar pod, so a pod that's attached to it. And all the traffic goes through the pods, the proxies. So ingress, when the request comes in here, it will, instead of going to front end, it will go to the proxy of the front end. And if front end wants to call the pictures, the proxy of the front end will call the proxy of the pictures, and vice versa. So all the traffic is proxied through these proxies. And because of that, Istio can do interesting things. It can set up rules, and it can monitor traffic. It can send metrics. So all the magic happens through the proxies. And one thing to note is that all the external traffic from your cluster in Istio is by default blocked, so you cannot call anything outside. If you want to call something external, like a payment system, you need to create what's called an egress rule. So in the egress rule, you explicitly say, from this cluster, I allow this endpoint and this port to be called, and once you create that rule, then Istio allows that. So by default, it's secure. You need to enable external dependencies. So to get Istio, first you need a Kubernetes cluster. So in Google Cloud, you would use G-Cloud Container Clusters create to create the cluster. And as you can see, this cluster is nothing specific. Like it's just a regular Kubernetes cluster. The only thing that you need to do is you need to set a cluster admin binding. So it's kind of like rules that you need to set up for Istio to manage it for you, right? So that's the only special thing about the cluster. It's a regular cluster where you just set a role binding, and with that, you can install Istio into this cluster. So let me just show you this quickly. I have a quick video. I wanted to do this live, but the Wi-Fi wasn't that great, so I didn't want to do it live, but I can show you the videos so that you have an idea. So this is Google Cloud Console, and then if you go to Kubernetes Engine, the managed version of Kubernetes in Google Cloud, I already created a cluster called Hello Istio. So that this is just a regular Kubernetes cluster, and now I want to install Istio into this cluster, make sure that it's managed by Istio. So what I need to do is first I need to get the latest version of Istio. I am just using curl. It's very hard to see, but basically I'm just doing curl https git.io get latest version, and then I will just say Istio version. So in this case, I'm downloading 0.4.0 version of Istio, which is not the latest right now. The latest is 0.7 something, but this is the one that I'm downloading. And then once it's done, we will be able to install Istio. And then one thing that you will realize is that Istio comes with default YAML files for installation, so you will basically just point to the YAML files and work that way. And also, Istio gets installed into a separate namespace, so it doesn't clutter your cluster itself. So we downloaded that. We go to Istio 0.4.0. Then the first thing that I'm going to do is I'm going to set my path to Istio's bin folder, because Istio has a command called istioctl that you can use to manage it. So I want to make sure that istioctl is in my path. So that's what I did here. And then next thing I want to do is just install Istio. So I'm here, I'm saying Istio apply, and then I'm just pointing to a folder, install Kubernetes Istio. auth. So these proxies that I talked to you about, the proxies that talk to each other, they can be mutually authenticated or not. But by pointing to Istio auth, I will make sure they are mutually authenticated. So they have strong identity and they are mutually authenticated. So that's what Istio auth does. So this installs all the all Istio, base Istio, and all the components of Istio into an Istio system namespace that we'll take a look next. So this usually takes like a minute or so. And then once this is done, and I can actually fast forward a little bit, which is a good thing about videos, you can skip. All right, so it's done. And then I can say kubectl. There's also something called Istio initializer that, you know, when you create a pod, we want a proxy to be created automatically. So for that to happen, I'm also installing Istio initializer that will basically watch my pod, and every time it's created, it will create a proxy for it so that the proxies work automatically. So I did that. And then if I do kubectl get services, and then pass in the namespace, so Istio namespace is the space that gets installed, then I can see that there's Istio ingress, mixer, pilot. These are the components of Istio that's already installed. And if I do get pods, we should also see some pods that's been created or it's running already. Let's see. So they're all running. So the certificate authority, ingress, initializer, mixer, pilot, all of them are running. So there's nothing special about it. You just download it and point to it, and then it gets installed into your cluster. So that's how you install it. Now, in terms of what Istio provides to you, as I mentioned, you can use it with Kubernetes, but you don't have to. You can use it with Mesos and Cloud Foundry as well. It tries to be platform agnostic. Kubernetes is the first platform that it aims to support, but it tries to be as agnostic as possible in many ways. Second thing it gives you is the observability. So everything that you want to observe about your application, it tries to give you something for that. For example, metrics. So it gives you metrics for free. It gives you logs. It gives you traces. It gives you dependency visualization. So how do your microservices depend on each other? You can get a visualization of that as well. It gives your services an identity and security. So all your services, they will have identity. And you can set mutual authentication between them. So you know for sure that this microservice is calling that microservice and no one else. And then for me, the favorite thing is traffic management. So in Istio, you can set rules about which microservice can call what microservice, and Istio enforces that for you. So you don't have to do that yourself. And the final point is the enforcement. So you just set the rules, but Istio is the one that's managing that for you. So you don't have to manage it yourself. All right, and now I want to talk about the building blocks of Istio. So as I mentioned, the proxy is the thing that does the work in Istio. It's where all the magic happens, I think. So the proxy supports HTTP1, HTTP2, gRPC, so different protocols. For those of you who don't know, gRPC, it's a binary protocol from Google that's open source. That's much more efficient than HTTP2. So if you want to use that, you can use it. But if you want to do regular HTTP as well, you can do that as well. By default, things are mutually authenticated, so you have TLS. But if you don't want to install it, you don't have to. So everything is like basically up to you, which one you pick and choose. So these are the proxies. And then there's something called Pilot, Mixer, and Istio auth that helps with proxy. So these are what I call helpers for the proxy. They help for the proxy to work the way it's supposed to work. So Pilot is all about discovery and configuration. So if proxy 1 needs to call proxy 2, it will ask the Pilot, where is this proxy 2? Because Pilot is the one keeping track of all the different services and discovery and all that kind of stuff. And also Pilot is the one you would talk to as a user to set the rules. So you will talk to the Pilot, and Pilot will convert those rules to proxy rules. So it will basically take your rules and push it to proxies as well. So that's Pilot. Mixer is all about telemetry. So all the traffic that goes through proxies, they generate telemetry, and that telemetry goes to Mixer, and Mixer keeps them in a central place so that we can visualize it later. But it also does policy checks. So if proxy wants to call the other proxy, it will first ask the Mixer, can I make this call? Because maybe there's a quota that you set, and the quota has been met, so maybe you shouldn't be calling, right? So Mixer is the one that keeps track of that quota, and it's the one that's enforcing that quota as well. And Istio auth is all about authentication. So if you want to set up mutual authentication, certificates, all that kind of stuff happens through Istio auth, right? So these are the main components. And I should just point out, Envoy, it's a high-performance proxy written in C++, and it's written by a company called Lyft. It's like Uber, similar to Uber, and they've been using Envoy for a long time. They have a cluster. Last time I heard, like 10,000 virtual machines, and they're generating like millions of requests per second that goes through these Envoys. So they're highly tuned, highly efficient proxies. Of course, it's a proxy, and this proxy adds a hop in your network, so there's a little bit of latency when you use these proxies, but it's not that much. I haven't heard many people complain about the performance impact of Envoy. And as I mentioned before, Envoy supports gRPC or HTTP2, and it's just a sidecar. So when your pod starts, it gets this automatically, and when your pod goes away, the proxy goes away as well. And we already talked about Pilot. So Pilot is all about service discovery and also keeping track of the configuration for the proxies. But another thing that the Pilot does is it abstracts the underlying infrastructure from users and from proxies. So what I mean by that is that as a user, you talk to the Pilot and you set some rules through the Rules API. So you use the Rules API and you set some rules, and Pilot takes those rules and it converts them into platform-specific rules. So if you are running on Kubernetes, it will take the rule and it will tell Kubernetes what the rule is and apply that rule. But if you're running on Mesos, it will do the Mesos translation. So it basically abstracts the rules from the underlying infrastructure, which is nice. But at the same time, it also abstracts envoys from the underlying infrastructure. So when Envoy wants to talk another Envoy, it will use the Envoy API and ask Pilot, where is this other service? And Pilot will figure it out, asking Kubernetes, and it will reply back to the Envoy. But the Envoy itself doesn't know that you're running on Kubernetes, and it doesn't care, right? So Pilot acts like an abstraction point for both users and proxies as well. And Mixer, as I mentioned, it's about checking preconditions, managing quotas, and reporting telemetry as well. So if any kind of telemetry you have, it will be reported through Mixer. And Istio auth is authentication. I have mentioned this already. So let me talk through this app. So I want to show you an application, and I want to look at some of these concepts through this application. So the application that we have is called Book Info application. It comes with Istio. It's a sample application. And in this Book Info application, you have requests coming in to a front-end page. This front-end page is written in Python. Then the front-end page talks to some microservices in the backend. So we have a Java microservice called Reviews. Then we have another microservice called Details, written in Ruby. And then there's a backend microservice called Ratings, written in Node.js. So a couple of things to note here. You can see that we have Python, Java, Ruby, Node, different languages. But it doesn't matter because these are all containers. So as long as you create containers for them, it really doesn't matter what language they're running in. And the second thing is that some microservices, they have multiple versions. So in this case, we have Reviews, version 1, version 2, version 3. That's OK with Istio. You can deploy multiple microservices, and you can pick and choose which one to use on the fly. So we'll just take a look at this application and see how Istio can manage this application for us. So first, we need to deploy the application. And to deploy it, we will say, just like a regular Kubernetes application, kubectl create -f and point to samples, book info, kube, and then bookinfo.yaml. So because we have Istio initializer installed already, when we create this book info application, every time a pod is created, a proxy also will be created for it. So we don't have to do anything special. So now all the microservices are created, and if you do kubectl get service, we can see that there's a details, product page, ratings, services. And if you do kubectl get pods, we see that the pods are either running or they're initializing as well. And then if you do pods again, now the whole application is running with all the microservices. That's nice. And then now to get to this application, we need to go through the ingress, right? Because everything goes through the ingress. So to get the ingress IP, I do kubectl get ingress and pass -o wide, and this will give us the address. And then I would set that address to a path called, to a variable called gateway URL, and I will use that variable to ping this endpoint. So if you do a curl to that gateway URL with /product page, I get 200. It's hard to see here. But then if I also copy this IP and go to this page, we should see /product page, we should see the application running already. But one thing to note is that in this front page, this is the front page with book details and the reviews microservice. And if I do a refresh, just see what happens here. So these stars are changing, right? They were red, and now they're black. If I do another review, they change again. The reason is because the reviews microservice, it has multiple versions. And because of that, every time I do a refresh, it goes to a different version, right? But we'll fix that later with Istio. But the thing is, there's nothing special about our application. We didn't change anything about our application. We just deployed it. And because we have Istio installed, and because we have Istio initializer installed, everything is set up. So there's nothing you need to do special about your application. That's the key about Istio. Now, once you have the base Istio managing your application, now you can add add-ons. And the add-ons, they're kind of like extension points to Istio. So for example, there's Grafana. Who's using Grafana here? Anyone? Okay, so you guys know what I'm talking about. Grafana is analytics and monitoring. So you can add on Grafana on top of your Istio cluster. You can use Prometheus to gather metrics and query them. You can use Zipkin for tracing, so HTTP tracing through Zipkin. And then you can do service graph. This is my favorite. So you can basically generate a service graph from your cluster and see how your microservices are related to each other. So as you can see here, by default, you have an ingress where everything goes through. Then you have the product page, that's the front end. Then this is calling different microservices, reviews 1, 2, 3. Then we have details, ratings, all that kind of stuff. And then you also have a backend, a MongoDB one. And you can see the dependency, and you can also see the requests per second, so bytes per second, stuff like that. So this gives you a really good visualization of your cluster. So to add these in, let's look at that. So Istio by default comes with a folder called add-ons. You just need to point to these YAML files to add them. So here I'm pointing to Grafana, and this will create a service and deployment for Grafana. And now I'm pointing to Zipkin. This installs Zipkin, and point to Prometheus, same thing. And then finally, service graph. And there's more add-ons, and you can also write your own add-on if you want to. It's very extensible. But I just want to show you the basic ones that Istio comes with. So once you do this, to test, what we can do is first of all, let's make sure that they're running. So if I do kubectl get pods, I see that there's the Grafana, and all the others are already installed. Now I'm sending some traffic to my application, so I'm just going to do some curl to my application. And as we are sending traffic, this will generate metrics, and it will generate some numbers that we can look at. So as I send traffic, the first thing that I want to look at is probably Grafana. So to set up Grafana, I need to set up port forwarding. So I want to make sure that port 3000 is forwarded to 8080, so I can hit it from the browser. So that's what I set up here right now. And if I open a new browser and go to port 8080, this opens up Grafana. And in Grafana, you get a default dashboard, Istio dashboard. You can just open that up, and that will show you your application and all the metrics about your application. Now again, keep in mind that I didn't change the application. I didn't add metrics to it. I'm not changing anything about it. It's just the proxy that gets installed with it and the traffic going through the proxy. It generates these numbers for me, which is nice. So you let Istio manage your app, but you get these for free. And that's the key thing about Istio. So you get all these different graphs for all the different microservices. I won't go through them in detail. You can take a look. But you just get this for free. The next thing that I want to look at is Prometheus. If I remember correctly, let's see. Yes. No, Zipkin. We are looking at Zipkin. So Zipkin is about HTTP tracing. So if you hit the main product page, what HTTP calls you are making and how long they're taking. You can see stuff like that. So once we do the port forwarding again, we can open Zipkin, and then under service name, there's a product page. We can hit that, find traces, and then in here we'll see the product page, the main page, and underneath you're going to see all the calls that's been happening underneath that page and how long each of them are taking. It's not a lot here, but if you have a more complicated application, you can see more things there. So that's HTTP tracing. Next one is Prometheus. So you have the metrics, but you want to query for them, you want to search for them, and you want to generate graphs from them. So for that, you can use Prometheus. Same thing again, I just do a port forwarding and then go to Prometheus. From here, you can search something like Istio requests, that's one of the metrics that we have. So Istio request count, and this will execute. And then you'll get the numbers, but you can also graph them if you want to, and see them in a graphical way that updates in real time as well. So you get this for free as well. And lastly, I want to look at the service graph. So the dependency graph, how do you generate that? Again, it's the same thing. You set the port forwarding, and then you hit that endpoint, and that will generate the service graph. So let's take a look at that. And then by default, I'm looking at one of the service graphs, but there's 4 or 5 different service graphs that you can look at. Some of them are more complicated, and some of them are more simple. I'm just looking at a simple one here to give you an idea what kind of graph you get. But this generates the graph on the fly, and within a few seconds, we should have the graph. Yes. So you can see the ingress again, product page, reviews, stuff like this. And I think that's it for add-ons. And last thing I want to talk about is traffic management. So one of the cool things about Istio is that you can set rules about how the traffic flows in your system, and you can also change them on the fly. So it's dynamically changeable, which is really powerful, because normally when you need to change traffic in your clusters, you need to involve sysadmins, you need to change load balancing rules, and those are not so easy to change. But with Istio, it's really easy. So some of the things you can do is basically dynamic request routing, so you can do A/B testing with Istio if you want to. Discovery and load balancing across services comes for free. You can do fault injection, so you can inject fault into your calls and see how your system behaves. And you can do failure recovery, so you can set retries, for example, like 3 retries for every call, and then Istio will retry for you without you having to do that yourself in your application. So it gives you a lot of things. I won't go through them in detail. I just want to show you the basics, but there's a lot of stuff in here. For example, let's say you have a service A that wants to call service B. It will just make a request to service B's DNS name. So it will say service B example.com, and then this will go through the proxy, the envoy, and the envoy will ask the pilot, where is this service B? Because the pilot is the one keeping track of where the services are. And then it will tell, the pilot will basically direct the envoy to the envoy of the service B. But then if you set a rule, for example, and said, I want 99% of my calls to go to version 1.5 of my application, but I want 1% to go to the new version, version 2, you can do that. You can set that rule in pilot. And then when envoy needs to make a call, the pilot basically directs most of the calls here, but then 1% of the time it will direct it here, right? So you can do this kind of stuff. But the key thing here is that the service itself, it's only making call to service B, right? It doesn't know that there's a rule. It doesn't know that there's 99% of traffic going to one place and 1% going another place. Only pilot knows, and because of envoy, we can do this kind of stuff, right? So that's something like this. And then you can also do user agents. So you can say, for example, if I have user agent Android, then I want them to go to these set of pods. But if I have user agent iPhone, then I want them to go to this special pod, right? So you can do header detection and then send traffic depending on the header as well. And then this is to say that, when service A makes a call to service B, it's the pilot keeping track of that, where service B is, and pilot actually doesn't know that. The underlying platform knows that. So in this case, Kubernetes actually keeps track of that. So it will rely on Kubernetes for that information, and from there, it will get it to the envoy, right? So the service registration and discovery happens through Kubernetes. All right, so let's take a look at these quickly. So you can change routes on the fly, I said, right? So if I do Istio CTL, get route rules, we see, that was too quick, so let me just pause here for a second. So in here, what I did is that I said Istio CTL, that's the command line tool to get your routes, and I'm saying get route rules, and then I have no resources found. So that means that I don't have any rules set up in my system yet, right? And since I don't have any rules in my system, if I go to my application and I do a refresh, this will keep changing because it will go to different microservice every single time. Now, I want to pin this version of microservice to a specific version, right? So you can do that by setting a route rule. Right? In this rule, I'm going to set all my microservices to use version 2 of their dependencies, right? So in here, I'm just saying Istio create, and then I'm pointing to a YAML file, and it says route rule all v1, sorry, v1. So I want all my microservices, and I will pause here for a second. I want all my microservices to use version 1 of my application. So the reviews microservice as well, it will use version 1. And once we do that, now the rule is created for all the microservices. And if you actually look at the YAML file, you can see that all these microservices, they have version 1. So that's how you set the rules. You just point them to the right version. And if I do a refresh, then this won't change anymore because I pinned my reviews microservice to version 1. So that's how you can change it. You can also do things like you can set specific users to specific versions of your microservice. So let's imagine you have a user called Jason, and you want Jason to always go to version 2 of your application. You can do that. And to do that, you, again, create a route rule. So we'll say Istio create -f samples, and then just point to a YAML file. And this one is route rule reviews test version 2. So this pins a specific user to version 2 of the microservice. And if we go here and do a sign-in, and now we are signing in with Jason, and you can see that this changed to version 2. And if I do refresh, it won't change. It will always be pinned to version 2 as well. So that's how you can do that as well. And if you want to get rid of these rules, it's very easy. You just do Istio delete, and that will get rid of all the rules. So you can add the rules, test it out. Once you're done, you can delete them. Everything is very dynamic and change on the fly. So we can change this. So this is deleting the version 1 of our rule, and now this is deleting the second rule that pins JSON to a specific version, second version. Yes, and if you go back here and log out, do a refresh, we are back to normal. This should change. Yeah, it's changing. Now it's back to normal again. All right. And the last couple of things before I finish in 5 minutes. So as I mentioned, also Istio is helpful for testing. So if you want to test timeouts, or if you want to do retries with some bounds, or if you want to limit the number of concurrent connections, so all this kind of stuff, you can set rules for that, and Istio will enforce it and make sure that it happens. And for me, one of the most useful features is fault injection. So imagine you have a front-end microservice calling a movies microservice, and the movies microservice is calling stars microservice, and you have this timeout. So this one is 100 milliseconds with 3 retries, and this one is 200 milliseconds with 2 retries. To test this is very difficult, right? But in Istio, you can set a rule that says, you know, I want this call to be delayed by 300 milliseconds, and I want this rule to be delayed by 400 milliseconds. Once you set that up, you can make the call and see what happens. Does your microservice behave the way it's supposed to behave? Does it rewrite properly? And if it fails, what happens? Do you fail over to something else? So all these scenarios that you should be testing in production, you can actually test them now by just setting these rules and letting Istio handle it for you. So that's fault injection. And you know, you might say, this is really cool, I like it, but I want to install it, but I don't want to keep it. It's very easy to clean up. So if you want to get rid of Istio, all you need to do is just say kubectl get pods, so you have your Istio and your application running, and you have so this is the application, this is Istio. Now the application is managed by Istio. All you need to do is just delete Istio, and that's it. Since it's in a separate namespace, it will delete that namespace, and then your application will keep running the way it's supposed to run, but it's not managed by Istio anymore. So in this case, I'm just deleting my application, but you don't have to. And then once the application is deleted, you can, I'll show you, you can do delete Istio initializer. That's the component that initializes proxies. You delete that. And then the next thing that you delete is the Istio auth component. So the base Istio and mutual authentication. By just pointing to a YAML file, you can delete them both. So this will delete all the proxies, all the pilots, mixers, everything that you installed, it goes away. So it's very easy to take it, try it out, see how it works, but if you don't like it, you don't have to use it. You can just delete it and your application will stay exactly the same way, but it's just not managed by Istio anymore. All right. And I think that's all I had. Yes, that's all I have. One thing to point out, again, if you want the slides, that's my Twitter. But I also have a blog post here, Istio 101 with Minikube. Minikube, it's a way to run Kubernetes locally. And I have steps on how to install Istio in Minikube and how to go through these steps that I show you yourself if you want to try it out. So on this blog post, I talk about that. So feel free to just go there and try it out. And we even have 3 minutes left for questions, which is great. I think that, yeah, that's what I wanted. So thanks very much for your attention. And if you have any questions, let me know. Any questions? And it can be in Turkish as well. I can switch. No? Efendim? Production'a hazır değil. Şu an 0.7. 1.0 olduğunda olacak. The question was whether it was production ready, and I'm saying that it's not ready. 1.0 olduğunda olacak. Ama çok hızlı ilerliyor. Yani mesela ben bu demoyu yaptığımda 1 ya da 2 ay önceydi. 0.4'tü. Şu an 0.7 oldu. Yani önümüzdeki birkaç ay içerisinde tahminim biri bulacak. O zaman kullanacak. Ama kullanan müşterileri de biliyorum yani. Yani production ready değil dememize rağmen kullanıyorlar ve çalışıyormuş. Burada. How much should we be concerned about the overhead Istio adds to network traffic? You should be concerned, but it's not that much. I guess that's the answer. I mean, we don't have hard numbers on what kind of overhead it provides. There's a little bit of overhead, but I never heard someone complain to the point that, you know, they say, oh, I'm not going to use Istio because there's so much overhead, right? Because, you know, Istio adds proxies, it adds telemetry, it adds all these features I talked about. What people usually do is they take a base system and compare it to Istio and say, oh, this base system is much faster than Istio. Yes, it is faster because it's a basic system, right? But if you add telemetry and if you add all these features to it, then it's not going to be as fast anymore, right? So if you do an apple-to-apple comparison, then it is comparable. But there's an overhead, yeah, that you should think about, but I wouldn't be concerned about it too much because, as I mentioned, the Envoy itself, it's been used at Lyft for a long time, and it's been perfected. It's been like optimized for these use cases. So if it works for them, I'm sure it will work for many people. Are you an advocate or a developer? Both. Yeah, I mean, my role is what's called developer advocate. So it means that half of the time I'm a software engineer, and half of the time I'm like this. I come to events like this, and I talk to people about technology. But it's not marketing or it's not sales. I don't care if you don't use Istio. It's up to you. I just tell you what I learn and what I think works for me, and it's up to you to decide if you want to use it or not, right? So yeah, the answer is both. But I'm not trying to sell you anything. Just try it out if you want. If not, then okay. All right. I think that's it, right? Any other questions? Okay. Çok teşekkür ederim.